Hello everyone. In this video we are going to cover classes in Python, more specifically the constructor and the destructor of a class. So how do we go about creating classes in Python? Well, it's as simple as just creating the class keyword, typing it out, and providing a name for your class. In this example we're going to be providing the point. Right, so we're going to be creating a point class. Here in between the parentheses, you usually put other objects that your class may or may not be inheriting from, but in this case, this is not something that we're going to cover. Right, so when it comes to designing and building your class, something that you need to think about is what happens when it's created. This is the role that's taken by the constructor. The constructor is called the beginning of life for the class when it is created. So how is that done in Python? Well, if we compare to C++, we would have to use the same name as the class and we'd go about creating what details we'd like. In Python, it's a bit different. We're going to define it just like a function. However, this is a method because methods are functions that are part of a class. So because this function is part of the class, it's a method. And it's a special method. The constructor of all classes is done with this keyword. So anytime you see this line, you know it's the constructor for the class. The use of the self keyword will come later. Right, so here I'm just going to keep everything simple and I'm just going to say point is created. And that'll be all that'll be called when we create our class. Next comes up is what's going to happen when we reach the end of life for this class. Well, we need to call the destructor. So it's another special method, but instead of using init, we're going to use del for delete. We'll have self. And let's keep this destructor simple. Print point is going to be destroyed. So here in Python, destructors have less of a role to play compared to other languages, especially like C++, because things like dynamic memory allocation aren't really a big problem. Init is where you would have all the setup for your function to see how you want to create the beginning of your class and if you need to initialize variables. And delete is for cleaning up everything. If there's a connection over the network you want to disconnect, or if there's some other sort of communication that you're doing, here's where you want to stop it. But for the most part, destructors in Python, there's not much use. So why don't we go about applying the class? So why don't I say p is equal to point, right? So here I'm calling the constructor of point and I'm going to provide it to p. So let's see what the result is. So here point is created. Well, that doesn't seem too right. Well, if we run it again, the constructor is created and as well as the destructor, and we can keep running it and the constructor and destructor are going to be consistently called. So what does self mean? In terms of Python, self means the class that's calling these functions, so it's self. So here, point itself is going to be calling these and this, right? And compared to C and C++, mainly C++ because objects aren't in C, but in C++, this is analogous to the this keyword for those who are comfortable with C++ and classes in C++. The self word is, the self variable is analogous to this. So when it comes to adding attributes, meaning variables that belong to a class, how does one go about it? Well, let's say point, well, this will be a 2D point. Okay, so here we're going to need x and y coordinates, but I can't just do something like this. I can't just do something like this because here these are locally created variables. So what I'll have to do to make them attributes is to prefix them with the self keyword or the self variable. So the class or the current instance that calls this constructor, it itself is going to have its own internal variables here, right? Which is nice. So now if I do something like print p.x, p.y, what happens if you run this? Hey, look at that. It's initialized, right? So when point calls init, it puts itself as a variable and it sets its own attributes to 0. So something that should be mentioned with Python is that all attributes are public. You can't have private data or protected data. You can kind of finagle your way into seeming like you have protected data and private data, but with a little know-how, you can access that. And for that case, you know, it's safe to say that all attributes and all data that belongs to a class is public. So when you're going about creating this stuff, make sure that the user pays attention to what they're doing. And more error checking will have to be done to make sure that the user or programmer or yourself are not mishandling the class. Here, there's a problem with the constructor, a possible problem. When I call the constructor, I'm always setting x and y to 0. Maybe I want to set it to a different value, right? And we should treat this as a function. We should say, hey, x and y, right? Here we'll call it and we'll say self x equals x and self y equals y, right? But this is no longer a default unparameterized constructor. This is a default parameterized constructor, right? So it became one type of constructor and now it's another. Python, well, as well as C++, allows us a methodology for merging the two, and that is through the use of default arguments. Here what I can do is I can say x is equal to 0 and y is equal to 0. I can provide default arguments to this. So I can create point and it'll be 0, 0. I say p2 equals point of 1, and let's print p2.x and p2.y. We'll have point 3 equals point of 3 and 9, and we'll print p3.x and p3.y. Right, so here I'm calling all three possible versions of this constructor. One where there's no parameters, so both of these have the default parameters and it's stored here. Here where only one of them is provided with a parameter, meaning that y will have to use the default parameter. And here where none of the arguments will be using their default parameter. Something to note is that default parameters need to be at the end. Okay? At the end of the function. We cannot have something like this. This is totally 100% illegal, and this is syntax error. Right, so we can't have something like that, but we can have something like this. This is totally okay. So why don't we run the code? Look at that. So when there's empty arguments, both parameters here are used, both default arguments are used. When one argument is provided, the other one refers to its default parameter. And when both arguments are provided with values, none of the variables have to use the default parameters because they already have parameters. So here we go. Here are classes. In the next video, we'll be talking about methods in more detail, the kind of different methods that you can use for applying to any sort of class we have, as well as special methods. And these special methods, they are used for the equivalent of operator overloading in C++. Thank you.